For centuries, humanity has gazed upon the night sky, our eyes drawn to a crimson beacon Mars. This enigmatic neighbor, draped in shades of rust and ochre, has captivated our imaginations, fueling dreams of exploration and colonization. Mars represents a new frontier, a chance to expand our reach beyond Earth and establish a lasting human presence on another world. But the journey to Mars is fraught with challenges. A harsh and unforgiving environment awaits us. The thin atmosphere, frigid temperatures, and lack of readily available resources present formidable obstacles. Among these, the scarcity of water looms large. Water is not just a resource, it is the lifeblood of any civilization. It sustains us, nourishes our crops, and powers our technologies. Without a readily available source of water, our Martian dreams will remain just that, dreams. The quest for water on Mars is therefore more than a scientific endeavor, it is a necessity for the survival and prosperity of any future Martian colony. Finding and utilizing this precious resource will be the key to unlocking the Red Planet's potential and securing a foothold for humanity among the stars. Why is water so crucial for our Martian ambitions? The answer lies in its fundamental role in sustaining life as we know it. Every cell in our bodies requires water to function. We need it for drinking, for sanitation, and for growing the food that sustains us. Beyond our immediate needs, water is a critical component of agriculture. Growing crops on Mars, a necessity for any self-sustaining colony, will require access to a reliable water source. Traditional farming methods, reliant on rainfall and fertile soil, are simply not feasible in the Martian environment. Innovative solutions, such as hydroponics and aquaponics, offer promising alternatives, but these methods still depend on a readily available supply of water. Furthermore, water can be broken down into its constituent elements, hydrogen and oxygen. These elements can then be used as rocket propellant, a vital resource for both travel to and from Mars. The ability to generate fuel on Mars would significantly reduce the cost and complexity of Martian missions, making exploration and colonization more feasible. Water, then, is not just a luxury, but a fundamental requirement for any Martian settlement. Its presence, or lack thereof, will dictate the success or failure of our efforts to establish a permanent human presence on the Red Planet. For decades, scientists have suspected that Mars wasn't always the arid, desolate world we see today. Images captured by early spacecraft like Mariner 9 and Viking revealed tantalizing clues: vast canyons carved by ancient rivers, channels etched into the Martian plains, and sedimentary deposits hinting at long-gone lakes and oceans. These geological formations painted a picture of a warmer, wetter past, a stark contrast to the present-day Martian landscape. The evidence suggested that billions of years ago, liquid water flowed freely on the surface of Mars, shaping its features and potentially even harboring life. This ancient water, however, is long gone, lost to space due to Mars's thin atmosphere and weak gravity. But its presence in the planet's history fueled hope that water might still exist on Mars, locked away beneath the surface, frozen in polar ice caps, or hidden in underground aquifers. The search for this hidden water became a primary focus of Martian exploration, driving the development of new technologies and missions designed to unravel the Red Planet's watery secrets. As our robotic emissaries explored Mars, their instruments confirmed what the geological evidence had suggested. Water does exist on Mars, though not in the abundant, free-flowing form of its distant past. Instead, it lies hidden, frozen, or chemically bound within the Martian soil. The planet's polar ice caps, visible from Earth, even through amateur telescopes, hold vast quantities of water ice. These icy reservoirs, if melted, could potentially flood the Martian surface to a significant depth, highlighting the sheer volume of water locked away at the poles. Beneath the surface, radar instruments aboard orbiting spacecraft have detected signs of subsurface water ice deposits. These deposits, buried beneath layers of rock and dust, vary in size and depth, representing a potential source of water for future Martian inhabitants. Perhaps most excitingly, evidence suggests the presence of liquid water beneath the Martian surface. These underground reservoirs, potentially fed by geothermal heat, could offer a more readily accessible source of water for future colonies. While the water may not be immediately visible on the surface, Mars holds vast reserves of this precious resource waiting to be unlocked and utilized. Section 5. Extracting the Martian flow. Identifying water on Mars is only the first step. To make use of these resources, we need to develop methods for extracting, treating, and storing water in the challenging Martian environment. Extracting water ice from the polar caps or subsurface deposits will require specialized equipment capable of drilling through layers of rock and ice. Heating elements could then be used to melt the ice, which could then be collected and purified for use. For subsurface liquid water, wells similar to those used on Earth could be employed, though modified to operate in the lower gravity and thinner atmosphere. Treating this water for human consumption will be crucial, as it may contain high levels of salts or minerals. Furthermore, innovative technologies are being developed to extract water directly from the Martian atmosphere, which, though thin, does contain trace amounts of water vapor. These atmospheric water generators could provide a constant, though limited, supply of water. The challenges of extracting water on Mars are significant, but not insurmountable. By combining ingenuity with technological advancements, we can unlock these hidden reservoirs and pave the way for a sustainable human presence on the Red Planet. Section 6. Terraforming a blue planet in the making. The discovery of water on Mars has also sparked discussions about a far more ambitious endeavor, terraforming. This theoretical process involves transforming Mars into a more Earth-like planet with a thicker atmosphere, warmer temperatures, and potentially even flowing rivers and oceans. Water plays a central role in many terraforming concepts. Releasing greenhouse gases into the Martian atmosphere, for example, could trigger a runaway greenhouse effect, warming the planet and potentially melting the polar ice caps. This, in turn, could release more carbon dioxide into the atmosphere, further accelerating the warming process. While terraforming Mars remains firmly in the realm of science fiction, it is a captivating idea that captures the imagination and fuels our desire to one day transform the Red Planet into a second home for humanity. The ethical and practical challenges of terraforming are immense, and the process, if ever deemed feasible, would take centuries, if not millennia. But the possibility, however distant, adds another layer of intrigue to the story of water on Mars. Section 7. Water-rich regions, oases in the Martian desert. As we continue to map the distribution of water on Mars, certain regions stand out as particularly promising for future colonization efforts. These oases in the Martian desert offer a combination of factors that make them ideal candidates for establishing permanent settlements. The poles, with their vast reserves of water ice, are obvious contenders. However, the extreme cold and months-long darkness make these regions challenging for human habitation. Regions near the equator, on the other hand, offer more temperate conditions and more sunlight, crucial for solar power. Some of these regions also show evidence of subsurface water ice, making them prime targets for future exploration and settlement. Canyons and craters, particularly those with evidence of past water flow, could offer shelter from radiation and meteorites, while also potentially harboring water ice deposits. By strategically locating settlements near these water-rich regions, we can maximize our chances of success and minimize the challenges of living on this arid planet. Section 8. A global endeavor, collaboration for Martian exploration. The quest to explore and colonize Mars is a challenge too great for any one nation to undertake alone. International collaboration will be essential for pooling resources, sharing expertise, and ensuring the long-term success of this ambitious endeavor. Already, space agencies around the world are working together on robotic missions to Mars, sharing data and coordinating efforts. This spirit of cooperation will be even more crucial as we transition from exploration to colonization. Joint missions, involving astronauts and scientists from multiple countries, will be essential for establishing a permanent human presence on Mars. Sharing the costs, risks, and rewards of this endeavor will foster a sense of unity and shared purpose, transcending national boundaries. The discovery and utilization of water on Mars, a resource vital to all life, further underscores the need for collaboration. By working together, we can unlock the secrets of this precious resource and pave the way for a future where humanity stands united on a new world. Section 9. Conclusion. A future shaped by water. The story of water on Mars is a story of hope, ingenuity, and the relentless pursuit of knowledge. It is a story that intertwines the history of a planet with the dreams of a species determined to reach beyond its cradle and establish a foothold among the stars. The challenges are immense, but so too are the rewards. The discovery and utilization of water on Mars will not only enable us to survive on this alien world, but also to thrive. It will empower us to grow food, generate fuel, and potentially even transform the Red Planet into a more hospitable environment. As we stand on the cusp of a new era of space exploration, the quest for water on Mars serves as a powerful reminder of our shared humanity and our boundless capacity for innovation. It is a quest that has the potential to unite us in a common goal and shape the future of our species for generations to come. And as we look to the future, we can envision a time when the Red Planet, once a symbol of arid desolation, becomes a testament to human ingenuity and resilience, a beacon of hope, and a testament to the life-giving power of water.